This was a requested video that starts right here with this guy. I picked this up at a trade show. This is an old General Models NW2. There you go. And it's got a nice patina to it. We've got big plans for it. So one thing that I started working on for the NW2 is a set of trucks for it. So I started with the AAR truck right here. And that's kind of the scale version, just off the blueprints. If you want one of those, you've got it, because I posted it to my website, so you can print one of your own. And then I modified it to fit one of these, which is Northwest Shortline, the Stanton drive. So that'll be the 40-inch wheel with the 145 tread, 8-foot wheelbase. And so fitting a couple of those, this is what we'll have in the end. So there's the overall chassis. And you can see the interesting bolster. It's just a 3D printed bolster to get the right ride height. Right, but the neat thing about the Stanton is they're all under frame. Which means that if you want to have something interesting going on above the frame, it'll allow you that flexibility. Right, so what we're going to do is a little bit of testing with this. Now, I've never used these before, these Stanton drives. This is a new one to me. I really like Northwest Shortline as a company, but I've not used this whole integrated product before. I've used their gear sets and wheel sets many times in other projects. So with the Stanton, you get 4 wires that come out of each drive. 2 wires for the pickup, 2 wires for the internal motor. So I'm going to try a couple different configurations. The way I have it wired up now, I put some extension leads on there and then some roach clips here, but we're right now in parallel. Parallel meaning all like wires go the same. So hot wire on the pickup on this truck, hot wire on the pickup on that truck come together, as well as the hot wire for each respective drive. And that's this connection right here. Same thing on the negative side. We can also try a series. So we'll have still parallel on the pickups and then series on the motor and see what we get there. But we'll do some test running and see what we get. So just to show you what it looks like down the track here. Okay, so the test setup is a track that we're going to go about 100 inches down the line here, and hopefully get some good repeatability with it. It's got a little power pack here. Got a timer, so we can time how long it takes to get to the end. A couple meters, so bring it up here again. We've got our voltmeter there on the right, and current meter, current needle tube, and we send down the track. These numbers right here, well, it's a decibel meter. I don't know how useful that'll be, but maybe we can, when we go by, get some indication on sound. You can maybe pick it up on the phone here as well. Ambient in this room is down around 41 decibels. Right there, right? So it is picking it up. And lastly, we're not in Cleveland. We're in Detroit because those are DT and I overhead catenary arches, right? It's something else I just completed here. So, but those will serve as kind of my gates here to start and finish. It'll help me give some reference who can have repeatable tests. So let's get cooking. Okay, test one. Now I'm back. Okay, I did 3 trials here. I found something really interesting. I couldn't run it in the same speed both directions consistently. So going out, the slowest I could get it to go was, without stalling, was 1.7 volts. Coming back, the slowest I could keep it going the whole 100 inches was 2.2 volts. That translated to a scale 7.58 mile per hour out and 9.3 mile per hour coming back. And I did that 3 times and got very repeatable results each time. So let me show that to you here. And if I bring it up to about 1.7 volts, that will make it. But if I just reverse it without increasing the voltage, we end up having one of the drives running and the other not. So if I slightly bring up the voltage to about 2.2, and then we're back in business. But we're a little faster coming back. So that's interesting. Coming back the other way, I can drop the voltage a little bit more. That's at 2 volts. You can hear just one of the motors is running. Bump it up just slightly more. So that's an interesting result. It's a little louder with the body. Amperage is a tiny bit higher. but the time is the same. And you also have to give it just a bit more voltage coming back, otherwise it'll stall. Okay, so in series, now I've got twice the voltage, pulling less amps. It's going a little faster though. A little bit louder. I could not get it to quiet down and slow down as much in series. And I'll show you why. If I lower the voltage just a little bit, I've got one drive running, one drive not, in series. And it's maybe a little bit worse in the other direction, but you got to really give it a voltage boost. To get it to break free. Not very desirable. So I'm not really happy with the series arrangement. Lastly, here they are at 6 volts for Eric Peterson. I want to see the noise. And we'll bring them up to 9 volts now. Okay, to have something to compare with, here's a Atlas out of the box SW8. And it consistently runs at 1.7 volts in both directions at about a 1/4 amp. It'll always make it to the end. Very quiet when it's crawling. Took it about a minute and 16, sometimes a minute and 17 to go in both directions, the full 100 inches. It does get a little noisy, louder. Right, but when we really bring it down below 2 volts, it's real nice. And again, that's stock. You can always work on them, but just to have a good baseline to compare with, that is what an Atlas switcher will give you. Box stock Weaver, chugging along at 2.2 volts. Any slower and it'll stall. A little noisier. But it's slow. Sounds a little different in the other direction. It will get pretty noisy quick though. But again, this is completely stock. You can do a lot to improve these with Northwest Shoreline wheel sets and gears and football bearings in them. A lot of things you can do. But just for a comparison, you know, even completely stock, bring it down to just over 2 volts. That's what you're starting with. Here's a great drive, but not good electrical pickup. This is the P&D Hobbies GP9 drive. And it's actually really smooth, but the electrical is always the weak on it. We gotta keep that up at 4 volts or higher. Yeah, it's pretty herky-jerky. A little under half an amp. Just to demonstrate to you the differences that can be made, here's the same drive, just powering direct. And it'll move at 0.7, 0.8 volts, no problem. So with better wipers, you can really get a lot more out of the P&D drive. Or going dead rail with the battery. Okay, class, what have we learned? Well, I think it goes without saying, but I'm going to say it anyways. This is the most unscientific test ever, but doesn't make it not useful and not interesting. I think it's both of those things. So any of these locomotives can be improved. This is just kind of showing a starting point before going further down the line. Obviously, this was all analog as well. So, we can get into DCC and that's fine, but, and we will. But to get started with, here's our results. I certainly didn't expect the Northwest Short Line underfloor drive to compete directly with anything that's going to have a large can motor. And I think it shows that, it doesn't. And that would be an unfair expectation. But that said, I'm hoping we can improve it. I think we can. We're going to pop it open next, take a look at what's inside, and then also put a decoder on it and do some additional testing. It was surprising to me how well the old Weaver hung in there. Not too shabby for what it is. So that's exciting. I've got plans for all of these to be highly detailed and also modified in the running gear. But right now the NW2 is what I'm focused on. So we'll get that rounded out. Those AAR trucks are the same trucks that are in Atlas SWs. So probably during or right after I'm done with the NW project, I'll take those side frames and make them available to fit an Atlas SW. That'll be a cool little project. And we'll see if we can get those done in brass as well, so they're a lot more durable. Okay, well, hopefully you enjoyed this and learned something. I know I did. And we'll keep tinkering here and see if we can get more out of these drives. Take care.